Now we'll perform the calculation reviewing figure 15-14B out of Stallcup's Electrical Design Book, Volume 2, and we'll do the calculation of the previous illustration we just looked at. Now notice in calculating the load in amps for this, we would apply in step 1 220.87, which is the maximum demand load that we obtained either from the utility or using a demand meter as outlined in 220.87 and exception where applicable. We come up with 78.4 kVA. Step 2, we are told to take 125% of 78.4 and gives us 98 kVA. Now that is what we have read now with the demand meter on the existing service, or the utility has given this demand load. Now we will apply the load of 15.1 kVA to that calculated 98 kVA in step 2, and we come up with 113.1 kVA. Table 310.16, we have to obtain what the 400 kc mil conductors have, amp-wise, and it's 335 amp. So we're working with that. So 113.1 kVA times 1,000 is 113,000 VA. We take that VA rating and divide it by 208 volt times the square root of 3, and we use 360 here. We come up with 314 amps. 314 amps is less than 335, and we can add that 15.1 kVA load, demand load, to the service entrance conductors without changing the service entrance conductors or changing any item in the electrical equipment at all. So you can see that this optional calculation for the service in accordance with 220.87 is much easier to do than to go through and perform that long drawn out standard calculation where you would more than likely would have to increase the service equipment in some cases, the service main, the service entrance conductors, the raceway system. So this is a way to do it. Now, why? Why do they allow this optional calculation? This is one of the things that I've been asked many times. Well, it's based upon a lot of your existing buildings. Your receptacle outlets was taken at 180 VA if they were non-continuous use, and that was every outlet. There was no demand. If the outlets were used on a continuous basis, they were taken at 225 VA, 125% times 180 to give you 225. But there was no demand on any of these receptacles. So the service load was high. The table 220.12 had a very large amount of VA per square foot to increase the service in size and make it larger than really what was needed. So it was easy to run this optional calculation because the NEC in previous times did not allow these demands that you have now in Article 220, which we will eventually look at. But if you wanted to really go through all these demands and go through the standard calculation as well as the optional calculation on all pieces of equipment in a commercial building, just visit our Chapter 23 of Stallcup's Electrical Design Book, Volume 2, and I think it outlines it pretty good with all the years of my experience as a designer, installer, maintainer, plans checker, and inspector, as well as a chief inspector. So I've just passed on to you what I've been taught, and I hope that this information up to this point for the service has been helpful. Next, we're going to look at a feeder where we will perform the same optional calculation, and that's coming up next.